All right. So, what was your definition for polyatomic ion again? So, multiple atoms put together that create an ion. So we have a series of polyatomic ions listed on the right that you just wrote down, correct? I'm so sorry. So let's take a look at ammonium. Ammonium. How many nitrogens do you have?
1.
How many hydrogens do you have?
4.
Altogether, when you put NH4 together, what is the charge?
+1.
1 plus. So, ammonium is an cation or anion? Cation, positive charge. Take a look at NO3. So, you see where it says NH4, NO3? What is the name of that? Name your cation, name your anion. Ammonium. We see that with the NH4. And your anion is nitrate. We see that with the NO3. Now, what happened to the charges? Overall, your compounds are what in charge? Neutral. All compounds are neutral in charge. So, you have 1 ammonium and 1 nitrate because +1 -1 cancels out and you have a neutral compound. Hey, what would the formula be for ammonium sulfate? What would the formula be for ammonium sulfate? All right, NH4, there's your ammonium. And what's sulfate? SO4, 2 minus. Right? You just referenced it on the table. So tell me this. For your ionic compound, how many ammoniums do you need to cancel out with the -2 of your sulfate? You need 2. So I need another ammonium so that when I combine the two together, I have a neutral compound. Now, how do you write the formula, though? N2H8 SO4. That is one way to do it. I prefer to do it your way, though. I want to keep ammonium together, NH4, because 1 ammonium is NH4. It bonds that way. I want to keep it together. How many NH4s do I have, though? So what property am I using right now? Distributive property. That 2 distributes to the N and the H, so clearly I have 2 nitrogens and 8 hydrogens. So, NH42, SO4, there's your formula for ammonium sulfate. So, as we go about these examples, you want to keep this table handy so you can reference it every time you come across a polyatomic ion.